This section for calculus is a continuation from 1.3, and for pre-cal it appears in a new section on 1.4. And this is limits of transcendental functions. So transcendental is just a fancy name to encompass trig functions, logarithmic functions, and exponential functions. So again, just a fancy name for something you already know how to do. So notice that I bring back a point that I put on a previous lesson, and that's that the limit of a function is found by just plugging the x into the function. Okay, it's that easy. So I put this same rule, and I give you an example here. If I'm doing the limit as x approaches pi over 6 of sine of x, I'm just plugging that pi over 6 into the sine of x, and then because of my unit circle, I know that sine of pi over 6 is 1/2. So the most important thing for you in this lesson is to make sure that you know your unit circle like the back of your hand. And if you haven't me before, we go over that a lot. It's going to make this really smooth. Now, there are 3 different scenarios that do not work out with a unit circle. It usually gives you like an indeterminate, which is when you get 0 over 0. And that's these 3 rules right here circled in red. Now, unless you're in BC, I don't want you to worry about this third one. This one, I know it looks like you're memorizing 4 different things. Most textbooks only show you this first one, okay? Because 0 times any number would be 0. Same thing here, and then sine of 0 is 0. You see how it would give you 0 over 0? So a over b are going to be coefficients. For example, if this is sine of 7x over 2x, then your answer would just be 7 over 2. Now again, most books only show you this one and make you work these out by hand. I like to expose you to all 4 formats of this one. So notice that the second one is just the first one flipped upside down. Okay, so whether the number times the x is on top or bottom, and same for the sign, you'll still get the coefficient in the numerator over the coefficient in the denominator, a over b. It also works if you have the sign on both numerator and denominator. And then the last one is identical to the first, but instead of a sine, it is a tangent. Okay? And then the second one is very specific. The limit as x approaches 0 of 1 minus cosine of x over x. This gives you 0. And these you have to memorize. Okay, guys? If you try and do them by hand, they'll give you an error. So you have to memorize these. And do realize that in both scenarios, they are limits only as x approaches 0. That's the only scenario that this works with, okay? So let's take a look at these first 3 examples, and then that's pretty much it for your notes. I'm just going to keep giving you more complex examples to look at. So here, I'm plugging 0 in, and I am saying tangent of 0, okay? And knowing your unit circle, you know that sine over cosine is how you find tangent, and at that location, when you divide the sine by cosine, you get 0, okay? For this one, I'm plugging pi into both x's, so I'm saying pi times cosine of pi, okay? And we know based off of our unit circle that cosine of pi is -1, so I have pi times -1, which gives me negative pi. And now for our last one, every time you see a trig function with an exponent, I want you to take a moment and rewrite it with a trig function on the inside and the squared on the outside. Okay, this is very important as we start to learn in our next chapter derivatives. Okay, this is going to be huge. So please, anytime you see a trig function with an exponent, that notation means that whatever you solve for the trig function, that answer is what you have to square. If you forget these parentheses, then you're only indicating that the x gets squared instead of the entire trig value. Okay? So this is going to be sine of 0. And then once I find sine of 0, I'm going to square that value. So the nice thing is that sine of 0 is just 0. And 0 squared is still 0. All right? So plugging in and knowing your unit circle is going to be huge in this lesson. All right, let's take a look at these next examples. These examples are coming out of the evens from the pre-cal sections that we use for calculus, in case you want to follow along. So the first one says the limit as x approaches pi over 3 of sine of x minus cosine of x. So I'm going to plug that pi over 3 into both. So I'm doing sine of pi over 3 minus cosine of pi over 3. Okay? Now at pi over 3, my sine is radical 3 over 2, and my cosine is 1/2. So the most I can do with this is just combine it, being that they have common denominators, and that's it. Okay? For my next question, I'm plugging 0 into both x's. So I have sine of 0 over 1 plus cosine of 0. Well, on my unit circle at 0, my sine is 0 and my cosine is 1. So I have 0 over 2. 0 over a number is just 0. Okay? If you feel like this is going a little too fast, feel free to rewind, rewatch. But hopefully you have your unit circle that down packed, that this does feel this easy, okay? If not, I encourage you initially to have your unit circle out next to you and keep taking a peek at it so you see how this goes. All right, I'm going to start to throw some exponential logarithmic functions in here. So I'm plugging 0 into everywhere there's an x. So I'm going to say e raised to 0 minus 1 over 1 plus e raised to 0. Now, hopefully you remember that anything raised to 0 is just 1. So I have 1 minus 1 over 1 plus 1. And we actually end up with the same exact answer as the last question. Okay? Having a strong foundation in your exponential rules, your logarithmic rules, and your unit circle is key. I feel like I'm going to sound like a broken record today. So let's plug here the limit as x approaches 1 of this function. I'm going to plug 1 in. So I'm saying ln of 1 over e to the first. Okay? Anything raised to the first power is just itself. So I can say that this is ln of 1 over e. Now, although that is technically a correct answer for you to leave it at, don't be surprised if in the back of the book or even the day you take an AP test, that's not what the cleanest version is. Remember that ln's and e's cancel out. So in order to cancel out that ln and e, I would have to rewrite this as ln of e to the negative first. I brought that e up with a negative exponent, and now this negative 1 can move to the front, and I have negative 1 times ln of e. Now that I have ln of e by itself, I know that ln of e equals 1, so it's like saying negative 1 times 1, which is just negative 1. Okay? Again, a lot of ln and e's and exponential rules going into play there. Let's take a look at the next ones. So, if your eye does not catch this initially, the better you have things memorized, the easier your eyes are going to catch it. You might try and plug in the 0. If you plug in the 0, okay, let's say you make the mistake of not catching that this is one of the special trig limit rules. You're going to get sine of 0, which is 0 over 0. Okay? So, 0 over 0 is it's something I can get out of a problem, but it's not a proper way that I could ever leave my answer. That just means I need to either check the rules that I've memorized or try and clean it using some other rule that I know. Now, this may be easier to see if I change that x over 3 to a third x, okay, over x. And now we have the limit as x approaches 0. I have sine of an x over an x, so I'm just going to use my coefficients. It's 1 over 3 divided by 1, which is just 1 over 3. And again, the more you have these memorized, the easier they're going to be to spot. This next one is definitely a harder one to spot, okay? I can kind of see that in here, I have one of those special trig limits. You guys see that there? Remember that I can split this into two questions. So I can say the limit as x approaches 0 of 2x over x minus 5 times sine of 3x over x. So all of this rewriting is allowed as long as you follow your rules. Notice here, these x's reduce. So I'm technically writing the limit as x approaches 0 of 2 minus 5 times sine of 3x over x. Now, this next part should feel pretty easy, almost too easy that you're going to question it. The limit of a constant is just that constant. So far, my answer for this first step is 2 minus 5 times whatever the limit of this is. Now, based on my special trig limits, I know that the limit here is just the coefficients, 3 over 1. So I have 5 times 3 over 1 is just 3. Okay? So hopefully you caught that this portion right here gave you this part. Okay? So now just follow PEMDAS. Make sure you multiply first. 5 times 3 is 15. So I have 2 minus 15. And you should get a negative 13. And that's your final answer right there. So the last piece of information I want to give you for today is a reminder on the continuity of some of these transcendental functions. I am a firm believer, and I always reinforce in my classes, that knowing your graphs is a huge help. Okay, remember that in order to do a limit, you have to be able to sometimes check for the continuity of the function. Okay, and so e to the x has an asymptote at 0, and then continuity is like the domain. So from left to right, the domain always exists. So an exponential function is always continuous. Where a logarithmic function, whether log or natural log, has a vertical asymptote, and its domain only exists from that asymptote onto the positive numbers. Of course, unless there's some sort of transformation where it shifts. So for the parent function, its continuity goes from 0, not including 0, which is why I put a parentheses, and then on into infinity. Okay? And then the two trig functions, although they start at a different point, they do go on forever without breaks. So these two also have a domain, and their continuity is always, it's always continuous. It goes from negative infinity to positive infinity. These are the only two trig functions that this is true for. Remember that the other four have infinite vertical asymptotes. So they have infinite pauses and breaks in their domain and within their continuities. All right.